Hello everyone, welcome to our course of business statistics. This course will take you to the journey from the raw data to the meaningful informations. Before I begin, let me ask you a question. What comes to your mind when you hear about the statistics? Is it a scary number or beautiful charts, mean median mode, standard deviation correlation? If yes, then we are going to cover all of these, let it be charts, numbers, diagrams, mean median mode, and other things. But numbers will no longer be scary for you by the end of this course. So, before I begin, let me tell you about an incident that occurred yesterday. I was planning a trip to Mumbai, and for that, I just searched in a Google about the flight for Mumbai. And then what happened? I start getting messages from the airlines companies and the hotels at Mumbai. Now my question is how these company knows that I am their potential customer. And the answer lies in the business statistics. Google is selling the data, and these companies are actually targeting the interested parties directly. But numbers tells you the story, but only those who understand the statistics can read it correctly and use it wisely for the decision making. Right? As rightly pointed out by the Carl Pearson, statistics is a grammar of science. Just as grammar gives meaning to the language, statistics give meaning to the data. In fact, without statistics, data is just collection of numbers. So let's dive down deeper into the course to understand what the statistics is and how it is helping us in decision making. If you develop a friendship with the statistics, you start enjoying the numbers. Now, before we start, there are two senses of defining statistics. One is plural sense and another is singular sense. Plural sense is referring to the specific numerical facts or data points in the statistics. For example, we can say that there is a match between France and Spain, and if I say that statistics favors France in the match, it means that I'm talking about the plural statistics. Something, a systematic presentation or collection of number, right? Or I can say that Sehwag is the best performer. It is a statistics in plural sense, right? Now, what is statistics in singular sense? Statistics in singular sense referring to the academic discipline, field of study, or methodology itself. For example, test of vaccine to control the virus, trying to find out if our statistics class has improved the performance of the students, and many others. So, for having a better clarity, I can say that statistics can be classified into two sense of definition. Statistics can be defined in two senses. One is singular sense and another is plural sense. In plural sense, it is nothing but data. That is numerical facts, right? Systematically collected. And data may be qualitative, not in numbers, or quantitative. And this data is collected for analysis, right? So, plural sense is indicating towards the number. as we say, oh, statistics are very scary. Statistics are poor. They won't be able to achieve something. All the statistics are in the favor of India winning the match. So and so forth. Coming to the singular sense, statistics is a systematic process, and systematic process of what? Collecting, organizing, analyzing, and interpreting the data. It is a method, it is a science of collecting, organizing, presenting, and interpreting the data. So, it is a tool of turning raw numbers into meaningful conclusions or insights, right? So, it involves all the steps from collection to organizing to presentation to interpretation, analysis, and interpretation of data, right? And this is used for decision making. Moving ahead, let us come to the origin of statistics or evolution of statistics. Statistics is originating from the Latin word called status, which means state. And another school of thought believes that it is originated from the Italian word called statistica. So it comes from the let Italian word statista, right? And there are many other school of thought. If we talk about its basic Latin root, which refers to state, it means that data that is collected and maintained for the welfare of the people in the state. Later on, in the 18th and 19th century, as shown in slide, it was used as a political arithmetic, where it was used for the methods of describing population, trade, and vital event like birth rate, death rate, etc. So things about vital statistics was recorded. By 20th century, statistics was developed into a modern form of statistics, which is like probability comes into picture, sampling theories, hypothesis testing, and experimental designs, etc., were used in statistics. And today, as we know, statistics is everywhere. With the emergence of data science and AI, statistics becomes even more important. And no field is now is ignorant of statistics. Let it be business analytics, public policy, or any field, right? Then moving ahead, let us come to the most popular definition of statistics. So, what is statistics? Statistics is a science of collecting, organizing, analyzing, and interpreting data to make informed decisions, especially under the condition of uncertainty, and it transforms raw number into meaningful insight. So, first of all, you have to collect the data to prove something, then you organize that collected data, then you are analyzing that data or presenting that data and then analyzing it, and finally interpreting that data. And you are using that data for drawing inferences or conclusions. Let us take one example. Suppose you want to find out if vaccine is effective in controlling coronavirus. Then you need to look at the population, means all the people who are exposed to coronavirus. And then you have to, so your population is what? All the people affected by the virus, exposed to the virus. And then you are select few of them as a sample, and you are going to collect the data from that people. So this is your first step. Data may be collected from the primary sources or secondary sources. In this case, we can collect the data directly from the people as a primary data, and then we are going to use the data for what? Decision making. So after collecting, what I'm going to do, I'm going to organize that data into structured tables or pictures, diagrams, etc. And thereafter, I can apply a suitable statistical test, and thereafter I can draw a conclusion about what? About whether the vaccine is effective in controlling coronavirus or not. Right? So statistics begin with collection of data, and then you are organizing that collected data into different summaries, tables, graphs, and diagrams, and then you are analyzing the data using the proper statistical test, and then you are interpreting the data for drawing inferences or for checking your hypothesis, right? Statistics is everywhere in everyday's life. If you talk about the business, you are using the statistics for your sales forecast, to check the trends in the revenues, quality control, your marketing research, etc. Then if you come to the sports, now if you whenever you are watching a match, you would have seen that lot of graphs are shown about the performance of the player, about like the performance of both the team, comparative performance, and then averages of individual players, etc. Right? And then coming to the medicine, and you widely using statistics for interpreting the clinical trials, vaccination effects, how much dose to be given for a better result. Statistics is helping you with these decisions. And then government, in macroeconomics, government is using statistics for census, employment rate, GDP growth rate, finding out the per capita income. Then coming to the weather, rainfall records, temperature trend, forecasting model, everywhere you'll find it in the predictions of the weather. Then technology, app usage, analytics, testing, recommendation, etc. Now, before I move further, we need to have a clarity about population and sample. So, what is population? Population is that set of data in which we are interested, which we want to study. For example, if I am planning to conduct a study to find out the effect of vaccination in controlling certain virus, then all the people who are exposed to that particular virus is my population. But since I cannot contact each and every subset or unit of the population, I cannot contact all the individual, I need to draw a sample out of it. And I am going to conduct my study on the few selected people. That is my sample, right? So actually sample is a subset of population, and it is actually representing population on which I am going to conduct a study, and then I'm going to draw the conclusion about the population on the basis of my study on sample, right? So it is very important that sample should be representing the population properly. So if I want to conduct a study, say if I want to conduct a study in our university only, in that case, all the student, undergraduate student or BCom, say BA or BBA will be my population. But when I want to study, I cannot include all the student in my study. So I need to take out, select few student out of the total lot of student, and that becomes my sample, which is a representative of the population. And then I'm going to conduct my study using that sample and then drawing the inference about the population on the basis of this. So inferences about the population can be drawn on the basis of my study on sample. And obviously in statistics, I'm relying on averages. So population, if I'm relying on population averages, these are called parameters. Mean of population and standard deviation of the population. These are parameters. And if I take the mean of sample and standard deviation of sample, these are called statistics. Sample statistics. And this is one of the important part of statistics where I am studying the sample, growing out of population, and then generalizing the result on the entire population. Now let us come to the two branches of statistics. One is descriptive statistics and another is inferential statistics. What is descriptive statistics? When we try to organize the data and summarize the data and present the data in the form of table, chart, summary, number, that is descriptive statistics. So descriptive statistics is nothing but the description or summary of the given set of data, right? And that data is like organized, summarized, presented using table, charts, and diagrams. And you are actually using different averages to describe your data, like central tendency, mean, median, mode, and dispersion, which include mean deviation, standard deviation, variances, etc. So descriptive statistics is just when you are trying to describe the data. It's just a summary of the data. But it is inferential statistics where you are doing what? Sampling. You are taking the sample out of population, one or more sample. If you are taking one single sample, this is your population. Uh, then this is like drawing a sample. And if you are taking more than one, then this becomes sampling distribution, especially when your population is unknown and its parameters are unknown. Then you are using sampling distribution rather than drawing a simple sample. And your concern is like sample should be representing the population. And once you are generalizing the result of the sample on the entire population, right? So when I studied the people who are given vaccination and who are not given vaccination out of population, and I found that those who are vaccinated recovers better or they are more protected against the virus, then I can conclude, okay, it means that vaccination is effective. And if the results are not suggesting it, then we can say statistics is not favoring it. Vaccination is not effective, right? So we are actually drawing inferences or conclusion about the population on the basis of our study conducted on sample. And this is called inferential statistics. In inferential statistics, I'm using the testing tools correlation, regression, ANOVA, t-test, z-test, all of these are the part of inferential statistics. So in the next part, we are going deeper into descriptive statistics. So what are the tools that are helping me in descriptive statistics? This is the first thing which you are doing with the data. Summarizing the data in a meaningful way. In that, what you are doing, you are preparing different tables, diagram, charts, right? And then you are looking at measure of centers, which is called central tendency. And what are the measure? Like mean, you have median, you have mode. Mean is the arithmetical average, median is positional average, and mode is a is referring to the frequency concentration, where lies the highest frequency. So measure of center is what? Mean, median, mode, which tells me where the middle lies. Then coming to the spread, so just knowing about mean, median, and mode is not sufficient because averages are sometimes misleading. So, are they equally consistent? No, you can't predict the scores of Kumar easily because there is a huge variation in the maths. Whereas, if I look at Sahil, he's quite more consistent. And this is where measure of spread or dispersion came into picture. This is very important. So what is the average difference? What is the risk? What is uncertainty level that can be measured with the spread? And third is like visualization. Nobody have a time to go through the huge data sets where you can present your data, which is which is giving you a lot of information at a single glance, right? So what you are doing, you are creating a visual for your data through the bar charts, histograms, box plots, line chart, scatter plots, pie charts, and lot of other diagrams such as ogives. Coming to the inferential statistics is nothing but when we try to draw inferences about the population. We are trying to draw the conclusion about the population, but we haven't studied the population. Rather, we have studied a sample which we have drawn from the population, right? So whether it will be a test of relationship, test of differences, or predictive analytics like regression. So broadly, if I divide it, so we can say it is helping with me with test of relationship when I'm trying to find out the relationship between the two variables. Another is test of differences, where you want to find out the difference between the two variables or two set of data. And then your predictive analytics like regression and ANOVA. So why do we study statistics? Because it simplifies complexity. It actually present a condensed form of my data. When we have a lot of data, statistics help me to present it in a concise, meaningful way, like percentages, averages, aggregates, etc. And it's help in it supports forecasting. We are using regression analysis where we want to forecast about the future, forecast about the sales, forecast about the possible demand, forecast about the rainfall, where we are trying to find out about the unknown variable on the basis of known variable. Why we need statistics? What is the purpose of statistics? Again, one purpose is like condensation. It reduces a large mass of data to a few figures only, which represent the entire set of data, like averages of India, performance of India, Team India, then how the scores are moving, your class average percentage, average possible sales, change in sales, etc. To draw a comparison about between the two teams, to draw a comparison about the proposals, different proposals, right? And then it is also helping me in forecasting, and then it is helping me in testing hypothesis, which is actually uh, a verification of the claim. If you say, okay, my classes are going to improve your scores, this is my claim. But if I want to find out a support for my statement, then I will look into a data. I will draw a hypothesis, and then I use statistics to check that hypothesis whether my claim is factual or it is a simple assumption drawn out of fallacy, right? And obviously, statistics is helping you in formulating the policy, decision making. This is the most important thing. And time and again, as we are moving towards AI, the functions of statistics is becoming increasingly important. Now, as everything have limitations, statistics too have the limitation. So what are the limitations of statistics? Statistics rely on averages. It is not studying each and every element in the sample or population. It is simply relying on averages. It is believing the averages. Lot of unit will be ignored, right? Which may sometimes be misleading when their data is not normal or there are outliers in your data. Second limitation is deals only with quantitative facts. Does it mean that you cannot handle qualitative data? I don't mean that. It means that if you want to study the qualitative data, then you need to convert that qualitative data into numbers, because statistics is handling the numbers only. It is dealing with the quantitative facts only. Third is result hold true only on average. So it is not representing a single stance. There may be some unit which are not even taken into consideration, right? And statistical laws are probabilistic. It's not deterministic. There are chances of statistics going wrong. These are probabilistic model, which means you are taking into account only the more likely events, but you cannot say for 100%. For example, I traveled to Shimla, and we have seen statistics of rainfall possibility. So while looking at the weather forecast, it was showing like possible snowfall, and it was also giving the chances like 70% likely. And for 2 days there was no snowfall. So it is only telling me that there is a possibility, quite good possibility, that snowfall will happen. But it does not mean that snowfall will certainly happen. However, on the third day, when we were about to leave, there was a heavy snowfall and we were trapped. Right? So, statistics is not a certainty, it is just a probability. And obviously, statistics can also be used for misrepresentation and giving a wrong picture of something. So, handle with care. Statistics can prove anything, but whether that thing is relevant for you or not, it's your decision. Poor statistics will give the poor result. Good statistics will give the good result, right? So it is up to you to choose the data properly, to choose the sample properly, and to choose the statistics where it will give you a fair results. Okay. Then I want you to spot the statistics around you. As you are moving every day, wherever you are going, you will find statistics surrounding you. So first of all, find out the statistics, then try to analyze, try to find out whether it is used in a singular sense or plural sense, and then you have to come to the third point, whether it is descriptive or inferential. And I hope that you will be able to draw the conclusion, all these answers or conclusion with 100% confidence. So what are the key learning from this session? First of all, two senses: statistics in singular sense, where it is a systematic presentation of the data, when the data is collected systematically, right, to present something, and a singular sense, which is actually a systematic method. And then we learned about two branches of statistics, which is like descriptive statistics and inferential statistics. And lastly, we discussed about purpose and limitation of statistics. So this is all for today. In the next class, we will be covering about the data, because after all, statistics is how to deal with the data and how to convert the data, raw data, into meaningful information. Hope you enjoyed the lecture. See you in the next class.